Okay, good evening, all of you. Today, I will explain about the second unit in this analog circuits, that is multi-stage amplifiers. Okay, right. So previously we have seen single-stage amplifiers, single-stage analysis. Okay, so here, why multi-stage amplifiers is necessary? It means we can we can improve the bandwidth, we can change the bandwidth, we can change the gain, or we can change the input resistance by using multi-stage amplifiers. Okay, but the difference between single stage and multi-stage is in single stage amplifier we had only one number of transistor, right? But in multi-stage amplifiers we can have two or three or any number of transistors. Okay, so generally we are preferring two-stage amplifier, so it is enough. In some cases, we requires three-stage also, right? Yeah. So and this is the multi-stage amplifier syllabus. So first we see classification of amplifiers. Next one is methods of coupling. Okay, then cascade and transfer amplifier and its analysis. After that, analysis of two-stage RC coupled amplifier. Then high input resistance transfer amplifier circuits. So in that there we will see about Darlington pair. Okay, after that cascade amplifier. Next bootstrap. Then analyze multi-step using FET. So first almost 80% of the section is about BJT amplifiers. Then only few sections is about FET, and the last topic is differential amplifier. Okay, so these are the contents in this unit, right? Now, so what is basically amplifier? Which improves the amplitude or which increases the signal strength of the input signal. Okay, right. And in amplifiers, of course, we can have two types of transistor models. One is BJT model, another one is FET model. Okay, so BJT is bipolar junction transistor. FET means field effect transistor. Okay, now, so in amplifier there are so many categories. So first we see depending upon the type of coupling in multi-stage. Okay, so we have basically four types of couplings. One is RC coupling, transformer coupling, direct coupling, and tuned circuit amplifier, or we can say impedance coupling. So the another name of tuned circuit is impedance coupled amplifier. Okay, so RC coupled means, okay, here the coupling elements are resistor and capacitor. That is called RC coupling. Similarly, transformer couple means the coupling element is transformer. Okay, so output of the previous stage will be connected to next stage by using transformer simply. Next one, direct coupling. So direct coupling means there is no connect coupling element between first stage and second stage. That is called direct coupling. And finally, tuned circuit or impedance coupling means it is a the coupling element is here inductor or inductor and resistor or a capacitor and resistor. That is impedance. That is called impedance. Next category is based upon the bandwidth. Bandwidth taken by narrow band and untuned amplifiers. The untuned means wideband amplifiers. We can call another name is wideband amplifiers. And these are the frequency ranges. See, so narrow band means amplification is restricted to a narrow band of frequencies around a center frequency. Okay, and these are essentially tuned amplifiers. Okay, another name is tuned amplifiers. Only for this narrow band amplifiers, we will get small bandwidth. Okay, narrow band of frequencies. Or another name is tuned amplifiers. And what is another type? Untuned amplifiers, or another name is broadband amplifiers or wideband amplifiers. So that means these will have large bandwidth. Okay, okay. So by using these untuned amplifiers, we will get the more bandwidth. And amplification is designed over a considerable range of frequency spectrum. Now, untuned amplifiers are further classified with respect to bandwidth. Okay, so there is a subcategory under untuned amplifiers also. So those types are, see, here we have four amplifiers. One is first one DC amplifier. So DC amplifier means direct coupled amplifier, and frequency range is DC to few kilohertz. So DC means obviously no frequency, that is 0 hertz. Right. Next one, audio frequency amplifier, and the range of this amplifier is 20 hertz to 20 kilohertz. Next, broadband amplifier, and The range of this broadband is AC to few megahertz, and video amplifier. So video amplifier frequency range is 100 hertz to few megahertz. Okay, right. And the gain provided by an amplifier circuit is not the same for all the frequencies because the reactance of the elements connected in the circuit and the device reactance value depend upon the some reactive elements. Okay, so these are the two types in amplifiers which are based upon the bandwidth. One is narrow band, another one is untuned. Okay, next. Now let's discuss about the coupled amplifiers. So already just now I have explained about RC coupled. So RC coupled means that here the coupling elements are resistor and capacitor. Okay, that means we have suppose we have two-stage amplifier, that is first stage and second stage. Okay, in the first stage the output element is resistor, and from that point we can connect those out resistor to second stage with the help of capacitor. So finally here the coupling elements are resistor and capacitor. That's why this is called RC coupled amplifier or resistance and capacitor coupled amplifier. And what are the points here? This type of amplifier is very widely used and it is at least expensive and has good frequency response. By using these RC coupled, we may get the good frequency response. Okay, see. So what I told now, in the multi-stage raised to coupled amplifier, the output of the first stage is coupled to next through coupling capacitor and RL. So this is the important point. In two-stage RC coupled amplifier, there is no separate RL between collector and ground, but REO, the resistance between collector and VCC itself, acts as a load, and this REO acts as a load resistor. Okay. Next, next type is transformer coupled amplifier. So what is transformer coupled amplifier? So, so transformer coupled means the coupling elements are resistor and capacitor. Coupling elements are transformer. So with the help of transformer, we can connect output of the previous circuit to input of the next circuit. Okay. So with the help of this transformer couple, we can improve the impedance matching. Okay. We can improve the current gain also. Overall circuit gain will be increased. Circuit gain will be increased, and also impedance matching can be achieved. But such transformer couple amplifiers will not have the broad frequency response. Okay, we can't get the good frequency response with the help of transformer coupled. That is small. That is small. We will get the small bandwidth because inductance of the transformer windings will be large. So transformer coupling is done for power amplifier circuits where impedance matching is critical criteria for maximum power to be delivered to the load. So generally, these transformer coupling will be preferred in power amplifiers. Why? Because in power amplifiers, the important point is impedance matching. Okay, so there we are preferring these transformers especially. That is about transformer. Next one, direct coupled amplifier. So direct coupled. So in the name itself we have the answer. Okay, there is no coupling element between first stage and second stage. That's why it is called direct coupled amplifier. Okay, so in this type, there is no reactive element L or C used to couple the output of one stage to another. The AC output from the collector of one stage is directly given to base of the second stage transistor directly. Okay, so here there is no coupling element from the first stage to second stage. So these type of amplifiers are used to large amplification of DC and using low frequency signals. So this is the advantage. Okay, these DC type of coupling amplifiers are used for large amplification of DC and using low frequency. And RC coupled amplifiers cannot be used for amplification of DC or low frequency signals. Okay, so to amplify the DC signals, we can prefer these DC coupled amplifiers, and we are not preferring RC coupled for amplifying DC signals. Okay, since Xc is the capacity reactance of the coupling capacitor will be very large or open circuit for DC. So if you take a DC signal, the capacity reactance will be very high. That means it acts like an open circuit because what is the function of capacitor? Capacitor allows only AC signal and does not allow the DC signal. So for DC, the capacitor acts as a open circuit. Okay, that is the reason. Next one, tuned circuit amplifier. So tuned circuit means simply we can call LC circuit, LC tune or RC tune, no problem. Okay, that is a combination of reactive element and resistive element. And another name is impedance coupled amplifier. Okay, another name is impedance coupled amplifier. So that means impedance means combination of resistor and inductor or resistor and capacitor. So in this type, there will be one RC or LC tuned circuit between collector and VCC in the place of RE. And these amplifiers will amplify the signals of only fixed frequency. Whatever the frequency you required, only that frequency will be amplified at the output. That's why these called tuned circuit amplifiers. Okay, which is equal to the resonant frequency. The tuned frequency formula F naught is equal to, generally the standard expression is 1 by 2 pi root LC. Okay, or you can say 1 by 2 pi RC. Okay, these are the different formulas. And these are also used to amplify the signals of a narrow band of frequencies centered on the tuned frequency. That is about tuned circuit amplifier. Okay, next. So, till now we have discussed about these coupled amplifiers. Okay, okay, my dear students. So, just to go through these points for 2 minutes. If you have any doubts, please ask me. Just go through this theory. Okay, everything clear? Right. Next. Okay. So next we'll see the distortion concept. Okay. So distortion. So what is meant by distortion? Simply distortion means, suppose if there is any difference between input and output signals in with respect to amplitude or with respect to frequency or with respect to phase angle like this, then it is called distortion. Okay. So if the input signal is a sine wave, the output should be also a true sine wave. Okay, but in all the cases it may not be so. That's why which we characterize as a distortion. So distortion can be due to nonlinear cases of the device, or due to operating point, or due to a long signal swing of the input from the operating point, or due to some reactive elements L and C. Okay, so many factors for this distortion. Okay, so based upon these, distortion is classified into three types. One is amplitude distortion, another one is frequency distortion, third one phase distortion. and another name is delay distortion. Okay. Now, first we will discuss amplitude distortion. So, amplitude distortion means there is a change in the amplitude. That means amplitude is not a constant here. There is a change in the amplitude values. Okay, this is mainly due to non-linear characteristics of the components of the device. Okay, that's why this distortion is also called nonlinear distortion or harmonic distortion. See, so what is the point here? This type of distortion occurs in the loss signal amplifiers or power amplifiers especially. So another name of power amplifier or loss signal power amplifier. It is due to the non-linearity characteristics of the device. So that's why. So this is due to the presence of the new frequency signals which are not present in the input signals. Suppose the input signal is 10 hertz, the output signal is some more than the input signal frequency. So that's why this is called harmonic distortion. Those new frequency signals are called harmonics. Okay. See, the input is 10 kilohertz, the output signal should also be 10 kilohertz, but some harmonics terms will also be present, hence the amplitude of the signal will be different. Okay, so such distortion is called amplitude distortion, okay, nonlinear distortion or harmonic distortion. Okay, next one, frequency distortion. So frequency distortion means so the amplification will not be the same for all frequencies. This is due to the reactive component in the circuit. Okay, so if the frequency is changing, then that distortion is called a frequency distortion. It is mainly due to the reactive components. What are the reactive components? Inductor, capacitor. Okay, that is called frequency distortion. Next one is phase distortion or delay distortion. See, there will be a phase shift between the input and output, and this phase shift will not be the same for all frequency signals. Simply, okay, the phase shift is different for a different frequency signal. It also varies with the frequency of the input signal. In the output signal, all the distortion may be present, or anyone may be present, because of which the amplifier response will not be good. Okay, so if the input starts from zero, uh, just assume, then the output will not be starts from zero. So definitely there may be a phase difference. So such distortion is called phase distortion or delay distortion. Right. Now, next one. The performance obtained from a single stage amplifier is often insufficient for many applications, and several stages may be combined, forming a multi-stage amplifiers. Yeah, already I told. Mainly why we are going for a multi-stage means if the amplification or the bandwidth or the any other response is not sufficient, is not sufficient, then we'll go for multi-stage amplifiers. Okay. Now, before discussing that one, just please go through these three concepts: amplitude distortion, frequency distortion, phase distortion. Please, all of you, go through these points for 2 minutes. Okay. Then I will move on to next topic. Please. So, see, in multi-stage amplifiers, we can combine any number of stages, two or three or four. Okay, and these stages may be combined forming a multi-stage amplifier. And these stages are connected in cascade. So cascade means output of the first stage is connected to input of the next stage. Okay. Okay. Now, the overall gain of a multi-stage amplifier is the product of the gains of the individual stages. Suppose generally, what is the gain symbol A? Okay, if we have two stages, then A1 is first stage gain, A2 means second stage gain, and the gain basic formula everybody knows that output by input. Okay, output voltage by input voltage. Now, suppose if you have two-stage amplifier, then the overall gain A is equal to A1 into A2. Suppose if you have three stages, the overall gain formula is A1 into A2 into A3 like this. If you have n number of stages, there we have this formula. Okay, A1 into A2 and so on, AN like this. Okay. Suppose if we convert this value in dBs, then we have to add the all individual gains. See, this is the gain in dB formula. The gain of each amplifier stage expressed in decibels. The total gain is sum of the gains of the individual stages. So this is the gain in dB formula. A1 plus A2 plus A3 and so on. A. Right now, suppose when we want to achieve some higher amplification than a single stage amplifier, it is common practice to cascade various stages of amplifier. See, in this figure, this is the two-stage amplifier. So here is first stage amplifier, this is second stage amplifier, and this is the equivalent circuit by using the H parameters. H parameter equivalent circuit simply. Okay. Now, so what is the point here? In such a structure, the input performance of the resulted multi-stage amplifier is the input performance of the first stage, while the output performance is that of the last time. So with this, we can understood that the combining amplifiers of various types, we can create those characteristics that are necessary to fulfill the specifications of a specific application. In addition, using feedback techniques in properly chosen multi-stage amplifiers can further increase this freedom of the design. Okay. Okay. Even we have next, we will see the feedback concept also there. Okay. We'll see this feedback amplifiers, and those feedback amplifiers are also used to improve the bandwidth and etc. Now, so from this figure, so this is a two-stage amplifier. Then what is the gain expression? AB is equal to AB1 into AB2 because it is a two-stage. Okay, if we have three stage, AB1 into AB2 into A3 like this. Similarly, and these are the formulas: current amplification formula, power amplification formula. Power amplification is power gain. Current amplification current. Okay, now so cascading transistor amplifiers. So see, this is a cascading first stage, second stage. So here VI1 means input voltage of the first stage. V01 means output of the first stage. Similarly, VI2 means input of the second stage, and V02 means output of the second stage. And RL means load resistor, RS means source resistance, and VS is equal to source voltage. Let us consider a two-stage cascade amplifier. Let the first stage is in common emitter configuration. So current gain is high. Let the second stage also is common collector configuration to provide high input impedance and low output impedance. So here some have some expressions. Current gain, we can calculate current gain, voltage gain, input impedance. Okay, by using H parameter concept. Okay, next. Let's see the design. Two-stage cascade amplifier. See, this is a two-stage cascade amplifier. This is CE. First stage is CE. Second stage is CC. Okay, and we have the different resistor values here, and so this figure is redrawn like this for simplification purpose. Okay, and both circuits are same, but there is a slight difference in the alignment of the components. Okay, for the simplification purpose only. Okay. So there is nothing changed. Just we change the alignment of the components to calculate the values. Okay. See these two figures. Just to observe these two figures. Is there any difference? Emitter is a grounded terminal. Base is the input terminal. Collector is the common collector is output terminal in the first stage. Similarly, in the second stage, base is the input, emitter is output, and collector is common terminal. And that collector should be grounded. Okay. The first stage is common emitter, second stage is common collector. Okay. Now, And so in this figure, what are the elements? Ri1 means input resistance of the first stage. R01 means output resistance of the first stage. R01 dash total output resistance of the first stage by considering RC1. Similarly, Ri2 input resistance of the second stage. Okay, R02 output resistance, R0 dash total output resistance of the stage. Now, choice of transition cascade amplifier configuration. Next. So by connecting transition cascade, voltage gain gets multiplied by what type of conversion we use? CC or CB or C. To get the voltage amplification, current amplification, only common emitter is used because for CE amplifier we will get the more gain when compared to CC and CB. Okay, because for CE amplifier, high input impedance and low output impedance. That's why CE amplifier is used to provide good gain. But CB configuration is not used since A is less than 1. But C, okay, but CC, since common collector amplifier, the voltage gain is less than 1. Okay, and for CB, the current gain is less than 1. So by considering these factors, we can prefer common emitter configuration. And this is the voltage gain, another expression. AB is equal to A into RL by RL. So A means current gain, RL means load resistance, RL means input resistance. Okay, right. Next, this is two-stage RC coupled amplifier. So first stage is common emitter, second stage is also common emitter. Just observe this figure. So here base is the input, collector is the output, emitter is common terminal. Second stage also same circuit. So generally we are preferring this type of circuit. See, one way to connect various stage and multi-stage via capacitors as indicated two-stage amplifier. The two stages of common emitter amplifiers are coupled to each other by capacitor C3. See these points. So what are the important points here? Just go through these 4 points and observe this figure. Okay. Hmm. Now, the most commonly used coupling is RC coupling. Already I explained that. Now, an RC coupling network is shown in the study above. The networks of R1, R2, and C1 enclosed in the dashed lines of the figure is a coupling network. And you may notice that the circuitry for Q&A is incomplete. So that is intentional so that you can concentrate on the coupling network. Okay, for the simplification purpose, this is the figure. Okay, now here the functions of capacitors are it allows the AC signal and blocks DC signal. Okay, already you know that the capacitor C1 blocks the DC of Q1's collector but passes the AC output signal. And R2 develop this passed or coupled signal as the input signal to Q2. And this arrangement allows the coupling of the signal while it isolates the biasing of each step. And this solves many of the problems associated with direct coupling. Now, see this figure. So for CECC amplifier, these are some circuits and the soft simplification of the circuit. And the another type of simulation, the first stage is CE configuration provides voltage and current gain. The second stage is CC configuration provides impedance matching, and this circuit is used in audio frequency amplifiers. So that is one of the application. Okay, and these are the some important formulas we are getting by the simplification. See, here we do. We just remember these formulas, and these are useful for solving the problems. Okay. So what are the equations? AV2 is equal to AV2 A2 into R by RA2, just AV2. Next AI1, very simple formulas. Okay, and these are the another equations. AV1, AI1, RI1. Okay, now see. So next important topic is high input resistance. So mainly this high input resistance means these circuits are using for the improve the input impedance or input resistance. Okay. Now, so in some applications, the amplifier circuit will have to have very high input impedance. So CC amplifier having high input impedance and low output impedance, but its voltage gain is less than one. If the input impedance is to be only 500 kilo ohms or less, we can use common collector configuration. But if still higher input impedance is required, then we go for this high input circuit. One is Darlington circuit, another one is one more circuit is booster is also there. Okay, so preferably Darlington pair. Okay, so here the important point is suppose if the input impedance required is approximately 500 kilo ohms or less than 500 kilo ohms, then 1 cc circuit is enough. But if suppose if we require more than 500 kilo ohms, okay, then only we go for these type of circuits, high input resistance circuits. That means in that one of the important circuit is Darlington pair. So Darlington pair means it is a two-stage amplifier which consists of two CC amplifiers. See this figure. So this is the Darlington circuit. The first stage common collector, second stage also common collector. Okay. So in this circuit, the two transistors are common collector configuration. The output of first stage Q1 taken from the emitter of Q1, the input of the Q2. Okay. Now analysis of this Darlington. See this figure. Okay. Okay. And then so the emitter, first transistor. So Darlington circuit is nothing but two transistors in common collector configuration connected in series. The same circuit can be redrawn as AC equivalent circuit. This one. So the DC is taken as ground. Okay, the DC is taken as ground. So see this, this is the DC. The DC signal we are connecting the ground. Okay, and you can see is ground potential, collector circuit and ground potential. And this is the equivalent circuit from this figure. Now, overall current gain is equal to two individual gains of it multiplied together. And Darlington pair current gain. So, overall gain is equal to HFE equal to HFE1 and HFE2. So, HFE1 means first stage current gain, HFE2 means second stage current gain. So, by multiplying these two gains, you will get the overall current gain. Right? Yeah, already I mentioned here. The HFE1 and HFE2 are the gains of individual channels. Both the transfer are identical. Then these are the equations. See, current gain, input impedance, voltage gain, output impedance. This is a very, very important. Okay. So write these formulas on a paper. Over. I will note down the formulas. Next, see the characteristics of Darlington circuit. 4 points. Very high input resistance, very large current gain, very low output resistance, and voltage gain is less than 1. Okay. So these are the also important points. Okay. Next. And this gives the Darlington wave very high input current gain and direct current gain, so approximately 10,000, so that only a teeny base circuit is required to make the page switch on. And the Darlington pair behaves like a single transistor with a very high current gain. It has three leads DC, which are equivalent to the leads of transistor inverting transistor. To turn on the, we have to give minimum voltage of zero point 0.7 volts across both the base emitter junctions, which are connected in series inside the Darlington pair. Therefore, it requires 1.4 volts to turn on. See, and this is the operation and other important points about the Darlington pair. Okay. And what is the operation? The Darlington phase are available as complete package, but you can make up your own from the two transistors. TR1, a low power type, but normally TR2 will need to be high power. The maximum collector current for a pair is same as the for TR2. Okay. So this Darlington pair is sufficiently sensitive to respond to the small current passed by your skin, and it can be used to make a touch switch as shown in the diagram. So for this circuit, which is lights and LED, the two transistors can be any general purpose low power transistors. The 100K resistor protects the transistors if the contacts are linked with a piece of wire. So these two transistors may be combined to form a configuration known as the Darlington pair, which behaves like a single transistor with a current gain equivalent to the product of the current gains of the two transistors. So this is especially very useful where high current needs to be controlled as an input pump amplifier or power regulator circuit. Thus, the Darlington transistors are available whereby two transistors are combined in one single package. The base emitter voltage drop is twice that of small transistor. And the disadvantages. The H parameters of both the transistors will not be the same, and the leakage current also more. So these are the disadvantages. Okay. Now, next, cascode configuration. So cascode means this first stage is common emitter, second stage is common base. Just see this figure and go through those points. Okay. Now, so in this figure, now we have a source resistor, source voltage, and this is two BJT transistors. One is NPN, another one is PNP transistor. Okay. Sorry, both are PNP transistors. Okay. So first stage is common emitter, second stage is common base, and these are the equations in cascode amplifier. Okay. Right. H parameters. Okay. And these are the standard H parameter values. So For a cascode transistor, the input Z is equal to that of the single common emitter transistor, and its current gain is equal to that of single common base transistor. So its output resistance is equal to that of a single common base transistor. The reverse voltage gain is very small. So there is no link between input voltage and output voltage. So in other words, there is a negligible internal feedback in the case of a cascode transistor which acts like a single stage CE transistor. Since HIE and HFE are same with negligible internal feedback. So HRE is very small. Okay. So what is the HRE value? Very, very less. See, in the order of microvolts. So there is a very small output conductance, a large output resistance. And 2 mega ohms is equal to the traffic common base stage. The above values are correct if we make the assumption that HOB are less than 20 kilo ohms. And these are the characteristics of cascode amplifier. Sorry, very large voltage gain, large current gain, and high output resistance also we will provide. Okay, and these are the features of cascode amplifier. Next, boost ramp. This is also one of the important circuit to improve the input impedance, input resistance. Okay, right. Now the maximum input resistance of the practical direct devices are only 2 ohms. High input resistance cannot be achieved because of the biasing resistors R1, R2, etc. They come in parallel with Ri of the transistors and thus reduce the value of Ri. So the maximum value of Ri is only 1 by HOB since HOB is the resistance between base and collector. The input resistance can be increased greatly by bootstrapping the Darlington circuit through the addition of CO between first collector C1 and B2. And here we can add the value. See this figure. This is the bootstrap. This is the additional capacitor C naught, which is connected between first stage collector and the second stage emitter. So by adding these capacitor, we can improve the input impedance. Okay, see the figure and go through these points. You will get some clarity, right? Just all of you read this theory. If you have any doubts, ask now. Okay, like is everything okay? This is formulas, input impedance formula, and this is equivalent circuit. Okay, it's equivalent circuit, and okay, and next. So then another last but one topic is two-stage RC coupled using FET amplifier. So till now we have seen the BJT RC coupled amplifier, and this is the RC coupled amplifier using FET. So that is common source configuration. So in common source, gate is the input terminal, drain is the output terminal, source is the common terminal for both input and output. Clear? Okay, that's why this is called common source configuration. And here we have two stages. Okay, in BJT, just like CE configuration, in fact we are preferring common source configuration. And apart from this, we have common drain and common gate also. Okay, common gate and common drain. So preferably we can choose this one. Okay, it provides high gain. Okay, see, the output V naught of the first stage is coupled to the input of the second stage through the blocking capacitor CV. It blocks the DC component present in the output of the first stage from reaching the input of the first stage, which will alter the biasing already fixed for active device. Resistor RG is connected between gate and ground. Resistor R0 is connected between drain and VDD supply. So CS is the bypass capacitor used to prevent Loss of gain due to negative feedback. The active device is assumed to operate in the linear region. So the small signal model of the device is valid. So frequency roll-off is the term used for the decreasing gain with the frequency in the upper cutoff region. It is expressed as dB per octave or dB per decade. And this purpose of this multi-stage amplifier is to get large gain. So with BJDs, common emitter can be used in fed and amplified common source configuration used. So already I told no. So for getting high gain in BJT case, we are preferring a common emitter configuration, whereas in FET we are preferring common source configuration. Okay, next. This is the last topic. Difference amplifier, or another name is differential amplifier. See, in normal amplifiers, we can have only one input. Okay, and that input will be amplified as the output. But in difference amplifier, we may have two inputs, V1 and V2. Okay, so the difference amplifier means it amplifies the difference between the two signals. Okay, so practically the output voltage is directly proportional to the difference between the inputs. So V naught is directly proportional to V1 minus V2. If we remove the proportional symbol, we can add one proportionality constant, that is V naught is equal to AD into V1 minus V2. So here AD means difference gain. Okay, but that is critical. But practically, we may have common gain also. That is AC. So AC means V1 plus V2 by 2. That is called common mode gain. And AD means difference gain. See these formulas. Okay. So V naught is equal to AV plus A2 V2. So this first one is common gain. Second one is difference gain. But from simplification, okay, and this is the formula. A naught equal to ADVD, but voltage gain of common mode gain. So general expression is ADVD plus ACVC. Here AD means difference gain, VD means difference voltage. Similarly, AC means common mode gain, VC means common mode voltage. To find out AD, this is the formula A1 minus A2 by 2. To find out common mode gain, this is the formula A1 plus A2. Okay. So from this is a one example. Yeah, we've taken some values. See, circuit of differential amplifier. This is the actual figure. So we have two transistors. See this figure, and two inputs and one common output. Okay, this is the difference amplifier. Okay, and in this we have different models. That is single input balanced output, single input unbalanced, dual input balanced, dual input unbalanced. These are the four types of configurations. Actually, this will comes in the next future classes. Okay, upcoming classes. And this is the circuit, and this is equivalent circuit, and these are the two types of modes: differential mode, common mode, and simplification, and this is the formulas equation. Okay, right. See these formulas. Okay, so this is about the today's session. Okay, I hope you understood all topics. Okay, so if you have any doubts, so please refer this material. If you have any doubts, ask me in the next class. Okay, okay, students, I love you. Take care. Bye. Thank you.